Good afternoon, everyone, or good morning, wherever you may be in the world. My name is Tom Kinzer, and this is a webinar for Introduction to the Power of Azure Synapse Analytics. For the next 3 hours, we're going to cover quite a bit of material, so you might want to take notes. I will take breaks as we can, but we've got a lot of material to cover and a short time to cover it. We want to jump right in. Now, this webinar is being sponsored by WebAge Solutions. At webAgeSolutions.com, you can find many different classes and training for you or for your company. Well, let's get started. The agenda for the next few hours will cover roughly 8 different areas, but some of these are much larger than others. Such as Intro to Azure Synapse Analytics. This is designed for someone that may be brand new to the whole concept. What is this product? What does it make possible? What can we do with it? This is a major feature service within Azure, and we want to look and see what all can we do with it directly, and also what can be integrated with Synapse Analytics. We're going to be looking at Serverless SQL Pools for the power of working with SQL. We're also going to look at Serverless Spark Pools for the same purpose, the computing power. How are they similar? How are they different? What can they do? What can they not do? And then we're going to look at number 4, Dedicated SQL Pools, for not only for the computer power, but for storage. And that's a big difference between serverless pools and dedicated pools. Now, the data that we're going to work with, no doubt, will be introduced into Azure through other means, such as maybe through files, unstructured, semi-structured, structured file content. Where are we going to put it? Well, we could always start with the Azure Data Lake storage. It'll be the second half of this webinar. We'll also look at some brand new features that have been introduced into Cosmos DB that will allow it to be integrated with Synapse Analytics. And that is Azure Cosmos DB HTAP. What does that stand for? Well, we'll find out when we get there. We're also going to spend a lot of time in Module 7. What are the pipelines? Do we have to use data flows? Do we not? Can we use notebooks? So there's a lot of variations within the pipelines, many different activities that you can use that brings a tremendous amount of power as you process your data. It may also eliminate the need for other tools. Now, if you are already using Databricks, you can continue to use that, and you can leverage Databricks with pipelines. Or you may want to move over to Spark Pools directly within Synapse Analytics. If you've been using the Azure Data Factory, you can continue to use it, or you can move that knowledge over into Synapse pipelines. Azure Synapse Analytics is the one-stop shop for everything you might want to do with data processing, supporting not only Microsoft proprietary formats and data, but open source formats, particularly working with Spark, Apache Spark, and notebooks. You can use either one, mix them together, integrate them, use both. It's completely up to you how you want to use the tools within Azure Synapse Analytics. So again, we still have a few more people popping in. Good. So let's get started with Module 1, an introduction to Azure Synapse Analytics. Why would you consider it? Well, it could be any of one of these reasons. If your solution requires integrating both relational and big data stores. For example, if you need to use SQL or some type of relational database that works with SQL, like SQL Server or other SQL databases, plus big data stores, which normally would be files that are formatted maybe as Parquet files, as comma-separated values, but you may have thousands of millions of these files that you have coming in. Or it could be coming into some type of event service, like the Event Hub or an IoT Hub built into Azure. You're just dealing with a tremendous volume, speed or velocity, and variety of data, and that would classify as big data. How do we integrate the two? You also may need to manage a data warehouse, which is probably going to act as the single authority on aggregated data and historical archive data so that you can perform maybe direct reports on it or run analytic workloads against it. Also, parallel processing. The dedicated SQL pool has massive parallel processing capabilities, and it can work directly with low-cost storage, which you would find normally in Blob Storage or your data lake storage, or you could move everything directly into the data warehouse, as in the second point. If you need to run this occasionally, it doesn't need to run 24/7. You may need to pause and restart, save money on not running the computing services except when you need them. You also may need to scale out. There could be a real demand in services and you need something to automatically scale, which is one of the primary reasons for moving to the cloud for most services, is that elastic scalability. And then finally, if you need to provide fast access to aggregated data, so having the data stored in the data warehouse across a massive parallel processing system with many different servers acting as the backbone of your services, you are going to see very fast access of aggregated data for immediate reporting, for real-time dashboards and near real-time dashboards, dealing with both batch data as well as streaming data. If any one of these are reasons for a new solution that you're trying to work with, then definitely look at Azure Synapse Analytics. What are the components of Azure Synapse Analytics? Well, first of all, you must have what's called a workspace that provides these components. The workspace is created in the Azure environment as a workspace service. Once that workspace has been provisioned, then you'll be able to access it either through the portal or through Synapse Studio, as you see here on the top right. Synapse Studio is a separate web interface that allows you to connect to your Synapse Analytics workspace and work with many of the other components, such as Serverless SQL Pools, Dedicated SQL Pools, whether you're using Synapse Spark, Synapse SQL, or Synapse Link, which connects to Cosmos DB. You may be leveraging Synapse pipelines, which in turn could call notebooks, whether they're Spark notebooks, Python, C# notebooks to act on the data, to process your data. With any type of data processing and ultimately to a data warehouse, there are multiple stages that would fall, as you see in here, under ingest and prep, model and serve, and then ultimately visualize for reporting purposes. As you can see, the ingest and prep category covers a wide area of different services that are available in Microsoft's Azure Cloud Services. The data can come from any number of places. Over to the far left of this diagram, it could be unstructured media data, such as images or videos. It could be logs coming from virtual machines or applications. But when we're talking about big data, normally we're talking about the last two, and that is a lot of files, unstructured, or a lot of records or pieces of information that need to be processed. The last one is structured data, which you normally think of as relational data, highly structured depending on a schema, so that we can pull that data into the entire process. All of that data could be immediately dumped right into the data lake storage or Azure Blob Storage services. Or the Azure Data Lake could act as an intermediate storage, where maybe we're moving across the top of this diagram and we occasionally write and read data to and from the data lake. So it could be that the files are introduced through the data lake storage, the logs, the media, or we could directly populate, maybe through code, into SQL databases. Now the column for ingest and prep, notice it's referring to these as different services available within Synapse as SQL and Spark and pipelines. And that's particularly talking about the Synapse SQL Pools, the Spark Pools, and the pipelines that allow you to process the data. Now Synapse Pipelines is a has a direct link to Azure Data Factory. They're virtually the same, but Azure Data Factory could coexist with a Synapse solution as a separate service. But if you're moving into Azure Synapse Analytics, you probably will start building your pipeline solely within Synapse and not necessarily with Azure Data Factory. So it's an either or both. So I want to make sure in this diagram we put those together. Synapse Pipelines has the same concept and functionality as ADF or Azure Data Factory. They both have the concept of a pipeline of activities that allow you to access and read and transform and load your data. Your ETL or ELT processing can be done with either one. And also Databricks. Databricks is leveraging Spark, Apache Spark, with notebooks. So you could also continue to use Databricks, maybe on premises or in the cloud with Azure Databricks, but notebooks are also now included within Synapse using Synapse Spark. So in this diagram, you could say Synapse Spark at the top and Databricks toward the bottom of this list are almost interchangeable. You can use Databricks as a standalone service within Azure, or you can use notebooks and Spark notebooks within Synapse and bring everything under one product. And then we have Azure Cosmos DB. Azure Cosmos DB has 5 APIs for storing non or no SQL data so that you can access the data very quickly through a geo-replicated environment. If you have 3, 4, 5, 10 copies of your data distributed around the world with Cosmos DB, and all the copies would be synchronized so that you have the exact same data in every location. So that's ingest and prep. We might ingest data from the far left into any of these products, start preparing it so that it can be used as a data warehouse, and that becomes the model and serve. So Synapse Analytics is going to allow you to work with the data where it is stored, back maybe over in Cosmos DB or what you see here down in the data lake, or move the data into a SQL dedicated pool and have the data stored within Synapse Analytics. Serverless SQL, Serverless Spark, and Synapse Link all connect back to the original store. They do not store data within Synapse Analytics serverless pools. But we are going to see what a dedicated pool is, so you can see how the data can be stored and distributed across multiple computing nodes. And then ultimately, we need to visualize it. Power BI is on this slide because it's Microsoft's premier reporting tool for analytic data. So it can connect directly into the data warehouse, but it also can connect all the way back to some of the original stores under ingest and prep, and even down to the data lake. So Power BI has a very flexible way of working with any one of these products, either individually or simultaneously, so you can mesh the data together for a dashboard or a report in Power BI. Now, we won't be talking about Power BI, and you may also have other tools, but we will see some graphing techniques that you can perform directly within your notebooks. So you may not need Power BI for some direct graphing of data. You could just use either Databricks or Spark notebooks that are also in Databricks. So let's start looking at the architecture of how this all fits together. First of all, notice in this diagram, the whole blue area is called Synapse Analytics, or Azure Synapse Analytics. The way you experience and the way you interact with it is with another interface called Synapse Analytics Studio, which is a web-based studio product. And we're going to create a workspace and bring up the studio in just a moment. But I want to make sure you see that what your studio is dependent on is the workspace referred to in this diagram as really the entire platform and how it works with other services. Within Spark, you'll be able to work with SQL, Python, .NET, Java, Scala, and you have other command line interfaces, not just the Azure CLI, but also the CLI for working with specific areas of Synapse. This incorporates not only how to manage the resources, but it incorporates security with Azure AD, such as RBAC security, role-based access control. And also with the data lake, you can introduce ACLs or ACLs to control access to different folders and files within your data lake. We have excellent monitoring tools to keep track of the data as it's being processed. And a meta store is basically describing the data as it exists in the data lake. So when we start working with the concepts of a polybase or a metadata storage, then all it's going to be doing is describing what is in external data sources, as well as describing what's inside your dedicated stores. Now that brings us to you need to be very clear about the difference between what's labeled in this diagram as form factors, dedicated versus serverless. I've colored these so they hopefully stand out. So you can see that SQL falls under both, but it's not handled the same. Dedicated is actually specific servers that have been set aside for your account to host your data if necessary. You do not have to host the data in the dedicated servers, but it's designed to do that. If you don't need to store the data, you might as well be using serverless. Serverless does not store any data. It only acts on the data, wherever it may be, however Synapse Analytics has been designed to link over to other types of data. And that's exactly why you see serverless in gray and SQL and Spark also in gray, because they are dependent on a data integration layer to work with your Azure Data Lake storage at the bottom of this diagram. SQL in blue with a disk indicate that it has storage. So a dedicated SQL pool includes distributed storage. Serverless SQL pools do not, but they both have a cluster of nodes or a cluster of machines that can act on the data wherever it may be. Now, Microsoft is working on more links to other types of data stores, but currently, what's not in this diagram, though, is that we could also link to Cosmos DB without moving the data into your dedicated SQL pools. And we'll see that as a separate section coming up. So what about the workspace? Well, let's create it. It's created within the portal, portal.azure.com. So let me switch over to my browser here. If I can find it, I may not have started it. Let's see. Oh, that's where it was. Okay, so I've already logged into one of my demonstration accounts, and up at the very top, if we just type in the word Synapse, you'll see that it pops up. Oh, there is a service called Azure Synapse Analytics. I select that, and I create a Synapse workspace. When you create a Synapse workspace, you're going to be working with resources in Azure, but at the same time, you're going to create another web interface to work with those resources. So you really have two portals to work with: the portal to create the base workspace, and then the portal or the website for the studio. So as with anything else in Azure, pick a subscription that's going to pay for it, pick a resource group, and Synapse also manages a separate workspace for you. So I'm just going to call this MRG demo for Manage Resource Group Demo, because Synapse is going to manage that for me. It's two separate resource groups. And then the name that I want to call it, I'm going to call it WS for Workspace, and just simply JTK, my initials, keep it short. Put it in the East US, that's where I am. In fact, I've got to tell you, I'm coming to you from Atlanta, Georgia, East Coast US. We're going to select a data storage, and we can pick one that already exists, or we can create a brand new one. Now, I already have one, but I need to make sure that it is a data lake. Now, I'm going to show you that. We'll come back to that in just a minute. And then what's in it, there is a file system area within that data lake called FS Demo. I could have set those up right now. We can click Create New, which creates a separate storage account, which will act as your default location for a data lake. But I can use multiple data lakes. This will also create a SQL environment, but I can create as many SQL databases too that I want with as part of Synapse or separate. All right, so let's look at security. What is the login to administrative credentials? And it's got SQL admin user. What is the password? And I'm just going to simply use a good old test one. Oh, I don't need that many characters. Let's use PA55W.RD. You'll see that because right here it looks like password, but it's a good old test password. Type it again. PA55W.RD. That matches. And then the rest of this allow network access to the storage account. Yeah, that really doesn't hurt right now, but I'll go, well, it's not going to let me do that now. In fact, it will be working with it locally. That's just only if you want it to make it available more broadly. And let's see, a double encryption, no, not necessarily. So we're going to keep it to an absolute minimum. Review and create, and let it rip. So this is going to take a few moments, but when it comes back, we're going to see a page like this, which will describe an overview of the workspace, as you see here. And there's two areas to get to the studio. Right here at the top, we have Workspace web URL in the top section, under Essentials. And this is the web address. Starts off with web.azuresynapse.net. And then the rest of it would be the information specific to your subscription and your workspace. Or down here in the bottom, there's a very simple open button that'll take you to that same location and open Synapse Studio. And that's really all you need to do within the Azure Portal. The Azure Portal is letting you create the workspace, and then all the work you do from that point on can be done in the studio. Now there is some overlap between the two, because if you look over here to the left, we can also start working on security. And in particular, we can look at the SQL pools, the Spark pools that are available, create new ones, get rid of old ones, or pause some of them as needed. Now there is also another pool that is under development. You'll see it labeled here as preview, and that's called Data Explorer Pools. We won't be covering that today, but Microsoft is constantly building on this one product, Azure Synapse Analytics, and you can expect it to continue to expand this year and years to come. All right, so let's see if our workspace has been created. Do a refresh real quick. It's still building it. And it does have quite a few components to build and set up, so we'll let that keep working as we continue with the slides. The studio will look like this when it's finally set up. And notice over to the left, we have different sections under the Synapse Studio, which are called hubs. We have the home, we have data, develop, integrate, monitor, and manage. So home is, of course, the home page is where you start. Data is going to show us workspace databases that are within the workspace, and also linked data sources that are outside the workspace that you can add in, such as a data lake or data sets or Cosmos DB accounts. Develop is where we can store SQL scripts, Spark notebooks, data flows, Power BI reports that we can build and work with directly within Synapse Studio. All of that will be under the Develop Hub. Now, integrate used to be labeled orchestration, and it is to build pipelines. These pipelines will be designed to ingest, move, transform by either using data flows, SQL scripts, and or Spark notebooks, all mixed together, or any particular ones you want to use. I've worked with some clients that really are heavily into Spark notebooks, so they continue to use them. They don't even have to use the data flows that are built into Synapse Analytics. Or someone that's very comfortable with SQL scripts, setting up SQL scripts as part of your pipeline. Any of those those are the three primary ones, but the data flow is very rich in different activities that can be that you can work with your data. And we'll see a section on data flow coming up. This is where you can see that under the integrate, you see that little icon is a pipeline. These are the same pipelines that you would use in a data factory. So Azure Data Factories is really embedded right here under integrate, and the functionality of notebooks taken right from Databricks or Spark notebooks is also integrated there within the develop. So develop and integrate is where you spend a lot of time building your solution. Now the last two are for primarily keeping up with what's going on, monitoring. You might want to watch jobs, the execution of pipelines, whether something ran or not based on a schedule. And then manage lets you manage all of your connections, your linked services, security. So it's a very simple set of hubs or menus. You can view them as menus that give you all the functionality and features to work with within the studio. Let's take a quick look back and see if we are done. It's still running. Do a refresh just to make sure. And a refresh of the whole website just to make sure I get the latest data. That's still deploying. But when it's finished, you'll see we'll have WSJTK, which is a workspace for Synapse Analytics, and we'll be able to link to the studio from the workspace. And then, of course, you could just keep the URL for the studio and go directly to it. You don't have to always go back through the Azure Portal. So the studio is not part of the portal. It is a separate web interface. All right, so let's continue now with part 2. Serverless SQL Pools are going to provide the computing power that we need. Very simple, fundamental facts you need to know about these serverless SQL pools. When you start up a Synapse Analytics workspace, you will automatically get one serverless SQL pool, but you can start others or create others. You can also define Spark pools separately. What's really cool about these serverless SQL pools is you don't have to create a database. You don't even have to create the objects that define the data. You can simply immediately start querying the data with SQL code back through to the data lake. There's no infrastructure to provision. There's no servers to set up, no virtual network, no clusters, and it does not include any storage. I'll make that very clear. It seems to be a common misconception when someone first comes to Synapse Analytics. When you see the word serverless, it really means no storage. It's storageless. There's no storage. And that means you can pause them or stop them as often as you want because it's simply computing power. There are underlying virtual machines that spin up as needed, automatically, predefined. There is, of course, the infrastructure that Microsoft provisions because this is a platform as a service. You do not manage the infrastructure at all. So that's one of the main reasons to use these almost immediately to start investigating and connecting to the data that's in your data lake. And in your data lake, these are in file structures. They could be comma separated value files. They could be Excel files. They could be Parquet files. There are many different file structures that will be supported in the data lake that you can use SQL syntax to query that data from the data lake. Pretty fascinating when we see how this works. So if this is serverless, then why do we also have dedicated SQL pools? Well, here's a comparison. Dedicated SQL pools do include storage. So one SQL pool, you'd have to know, well, is it dedicated or is it serverless? Because if it's dedicated, that means you defined what kind of power you want, what are you willing to pay for, and how you're going to persist that data. Now, a dedicated SQL pool can be running in order to serve up the data as well as store the data, or it can be paused, which means it still has data in it, but you've stopped the computing power temporarily. But if you get rid of a SQL pool, you're also going to get rid of the data. So be very careful about how you treat these. A serverless SQL pool, you can get rid of the pool but not lose any data because it's not really in the pool. So that's the biggest difference between these two right off. Dedicated, you can view as persisting the data. It includes the storage, and that storage is in the cluster of machines that make up this one pool of nodes. Serverless SQL pools, even though they don't have the storage, they do have the computing power to read data in a distributed form. The dedicated SQL pool used to be called the SQL data warehouse, and so it does still provide the data warehouse functionality or the operations. You also can define a dedicated SQL pool for a very specific throughput and size, so you always have a predictable performance and a predictable cost. Now, the cost will always include storage, whether your power, the computer is running or not. You still have to pay for having those provisioned and holding that data. But you turn it on, of course, then it revs up that power, and now you can start reading and writing and processing the data directly within the data warehouse. And that's that last point. It reserves processing power for data stored in SQL tables within the data warehouse. Serverless, though, is what we're talking about in this section, and it allows you to explore, prepare the data, but all of it's external. It is a SQL endpoint, so you can continue to use it as a SQL interface to your data lake. It enables interactive querying of the data stored over in the data lake. It relies on a technology called Polybase to help define the translation of SQL commands to files in order to not only read, but you can write data. You can write data through either one of these back into the data lake. Both of these use Polybase to work with a data lake. It's only the dedicated SQL pool, though, that we can load data in and keep it there and persist it. So because of that, dedicated SQL pools can be much more expensive than the serverless SQL pools. So don't use a dedicated SQL pool until you're ready, until you know this is the data that I want to keep, and this is the structure that it needs to be in so that I can perform data analytics on it as well while it's in a data warehouse. But there are many opportunities, though, to perform data analytics without storing it in a data warehouse. And as you're processing and staging the data, you may be using serverless SQL pools for most of your steps, and then ultimately storing it in a dedicated SQL pool. So the real purpose of serverless SQL is for these three main areas. Data exploration. Browse your blob containers or your data lake storage accounts. Blob containers do not have nested folders, but a data lake does. So you can investigate multiple levels of folders and all the files within every folder. So you can start seeing what's there, get the initial insights, perform analytics directly on that data in the data lake as a big data process. Whether you're using Hadoop or Spark, notebooks, SQL, all of that can be acted on right within the data lake. You can also explore the data graphically or programmatically through the tools that we're going to see within Synapse Analytics. Transformation. If you need to change the data, maybe you need to read it in its raw form, add some data, strip out data, correct the data, write it back out. So you don't really need a permanent SQL storage database. You could write things back out to a different part of the data lake. In fact, we're going to see how that's referred to as Delta Lake the Delta Lake, DELTA, is allowing you to move through and store the differences between each stage that is normally referred to as bronze, silver, and gold. You have a bronze layer for the raw data, silver for the intermediate layer, and gold as the final state that you would like to maybe continue moving it maybe over to a physical data warehouse. All the while, though, you're using Serverless SQL Pool, you still can treat the underlying data as a logical data warehouse. Notice that keyword logical. That means the data is not really stored in the Serverless SQL Pool. It is only described with metadata describing the tables or files in your data lake. So it's a syntactical layer, a metadata layer that describes the data in SQL terms, even though the data is not stored in a SQL database at all. So you can use the same SQL select commands to retrieve data and even also write to the data and explore the logical objects that define that external data. Still supporting T-SQL. So both serverless and dedicated SQL pools work with the same language. You don't have to learn a different form of the language across these different ones. But with serverless, you can't store any data directly within it. So you're not going to create any objects to store data like a table. You can't create a table inside a serverless SQL pool. There's nowhere to store it. But you can create an external table that describes external data. And that's the secret. They're building a logical data warehouse with only using your serverless SQL pool. What kind of files will you work with? Well, in the data lake, probably the best performing and the preferred file format is Parquet. But it doesn't have to be. It could be JSON files. It could be CSVs, comma separated values, or delimited text. And even in that raw form, in its original state, however you're capturing it into the data lake, you don't need a SQL database, even just to read the data. You use a function called open row set. So you select using an open row set that's going to convert those files into something that's understandable within SQL. You can also create a database and then describe the files with an external table. Whether you use open row set or you create external tables, they both will allow you to select the data, query the data, which goes all the way back to the original storage in your data lake. You can also write to the data lake by creating external files with what's called CETAS. Abbreviation is create external table as select. So you can select data from one other external table. The results could be written to yet another external table, allowing you to transform the data and keep it in the data lake. Powerful stuff here. But keep in mind, though, that if you need that speed, you need that turbocharged speed of running analytics across your data, you cannot beat dedicated SQL pools in speed. There's a lot of transformation going on here and a lot of interpretation through the different layers. So this will not be as fast as working with a dedicated SQL pool, but it's still a great place to start to explore and understand your data before you move it into more expensive storage, such as the dedicated SQL pool. So within the Synapse Studio, we can start exploring our data lake. Here is a screenshot of the data hub. And notice on the top left, we have Workspace versus linked. What this is showing is that there are data capabilities within the workspace itself, and then there are linked or bridges out to other services. And that's, of course, where you'll find the data lake. The data lake is not in your Synapse workspace. It's any other storage account that you want to link in. Now, when I first created my workspace, I did point it to a storage account to start with. but I can add many more here. In fact, in this example, we see one is ASA Workspace, another one is ASA Data Lake down there, and we could add another and another and work with multiple storage accounts. All right, let's hope that our workspace is ready. Yeah, there we go. And we're going to go to the resource group where it was created. There it is, WSJTK. So here's my new workspace. I try to keep it short with WS and my initials. So WSJTK is going to be the workspace in my Azure account that's going to host these components, and I can work with them through the studio. To get to the studio, I can either choose Workspace Web URL, click this link, or even easier, well, not necessarily easier, but a little short link down here that says open it. So open the studio. Either way will work. So I'll start with the top one. Takes me into a completely different web interface. Log in with the same account that I created it with in the portal. And now I'm in the studio. This studio has the primary hubs here on the left: home, data, develop, integrate, monitor, and manage. Go ahead and accept the cookies up here. And then if I navigate into the data hub, notice I've got workspace and linked. If I go over here to linked, then automatically I have that data lake storage. If I expand it, it shows me, well, there's also where inside of here, my workspace JTK, that is my primary, well, that is my only workspace, but it's also saying my primary storage is SA for storage account, SJK. Expand that. And that's now going to connect into my storage account and show me that I do have a container called FS Demo, and I also have a container called WWI02. Well, where did that come from? Well, let's just go back. I had that already created before the class, and if I go under my storage accounts, this is a storage account that was created with the hierarchical namespace enabled, which creates a data lake, hence the name data lake storage. Within my data lake storage, I have two containers, which are the root names of all your storage in the data lake. One is called FS Demo, one of them is WWI02. As I navigate into any one of these, I have folders within folders within folders, holding financial data in this rich structure from year, quarter, month, all down to the day. If I open up a particular day, it's going to tell me, okay, here's a Parquet file with the transactions for that day. This structure up here at the top is what you're responsible for creating in your own data lake. So all I did was point it to this data lake so that I can consume this data through Synapse. So let's follow this same structure here to bring in some, or to look at some data. So if I open up WWI02, I've got different information here, profiles, data generators, cells. Let's go to small, since that's a small file, just for faster activity. I'll double click it. Got two different years in here. I'll go to 2019, double click it, last quarter, last month, last day. So I'm going all the way to the end of the year for 2019, and there's only one Parquet file there. Now, what's interesting about the way this works too is that you don't have to put all your data in a single file. In fact, it's recommended that you do not. You can have up to 60 files that can be read simultaneously whenever you read this data from one of your pools. So don't try to force all your data into one, because that's actually detrimental. You have a cluster of nodes that can act on your data simultaneously, asynchronously from each other. So the more smaller files you have, it actually produces a better result, because you've got multiple machines grabbing those files as they can. For demonstration purposes though, we're just going to use the one file. It's 45 megs, you can see out to the far right, and it has data within it. Now, if you haven't worked with Parquet files, they're not a Microsoft proprietary format, but they are supported by Microsoft because they're an excellent column-based compressed format for hierarchical data, as well as compressed and easier to consume. So they are recommended. You still can use JSON. Now JSON is text-based, it's not compressed, but if you have a lot of small JSON files, it may be, it may be as fast, especially reading multiple files, but they still have to be parsed and extracted. Regardless of whether you use JSON, Parquet, XML, CSV files, we have Polybase to interpret it so that it can be treated the same way. The same SQL statements inside Synapse can work with different files. Now to see that, we are going to right-click on this Parquet file and have it generate a SQL script. The SQL script will allow me to either retrieve data directly from the data lake, that's select top 100, or give me the syntax to create the definition of that file externally, or we'll see later on too, how can I copy the data into a dedicated SQL pool with bulk load. So let's start with just the top one. Select top 100. Notice what it did. It created a select statement, top 100 from, and there's that open row set. The open row set is a SQL function that says connect over to this path, which is a URL into the cloud, and you're going to find that the file that we're pointing to is in Parquet. So giving it a hint or a direction, you need to interpret this file as Parquet, and then we can run and get the results. If I run it, takes a few minutes to open up the data. Well, not a few minutes, it should be a few seconds. And notice I've got results down here, and the results show me the data within that file as containing this content. This is a file. And I can continue to use open row set. In fact, I can run it again, or as often as I need to. And I could also run it across multiple files. If I had 20 Parquet files at that location, I wouldn't be specific to the file name like you see here. I could use a wildcard and say read every Parquet file in that location. But this is saying read just the one file, interpret it, turn it into a result set that SQL understands, and return it as a result set in this window at the bottom. I have no database. I have no tables. I am reading that data straight out of that Parquet file as if it is SQL stored code. That's powerful. Very easy for you to start investigating, looking at the data, see what you expect to find in it. This is the data in its raw form. But I could turn around and clean up some of this data and write out a different file and write back through this exact same concept here with create an external table. So if we back up, in fact, up here at the top, these are individual screens or files. So I can close out this SQL script, not save it. And then I said, well, let's try something else. Why don't we create an external table? Create an external table is going to describe the metadata of what this table contains within it. But notice it's saying, okay, where are we going to put this? This is showing me that I do already have a SQL pool that was started. Remember, there was one created for us. And click this drop down list. All right, so this one is created automatically. It is serverless. So when I create a table, it needs to be placed in a database. And notice right now, there is no database. So I'm going to create one. We'll call it SQL demo. You know what? Let's call it, well, I'll call the other ones dedicated when I have that in there. So let's call this SQL demo like I had. Create it. So this is a database inside the pool. And this database in this pool is only for metadata. It will not contain data. It only describes the data in the data lake. What will the external table name be? Well, let's call it what it actually has in the file name. We'll call it cell small. I'm not going to give it the date because I may want to add other dates to it later, or all the other files may have the same format. So I could use the same format on the others. And then notice too that it will either create it automatically or show me the SQL script that I could execute to define it. All right, open the script, and there it is. I have create external table, which basically says this is a description of the data, not in this database, but at this location right here. WWI02 is the name of the container at this location. And then following that path, tack on the rest of this. Here is the rest of the path within that container to get to that Parquet file. And I could later on come in and change this and maybe change it to a wildcard or even include multiple months and days as part of the table itself. All right, so this table does not exist yet until I run it. So let's do that. Now notice up here it says, what pool are you going to run this on? It defaulted to built-in. What database are you going to put this in? And there it did. It created the SQL demo database. Surprised it didn't already pick that because that's what I already answered. And then click run. This will find the external, see if it's already there, and if it does not exist, then it will create the rest of this. It says it completed with errors. Oh, bad syntax somewhere. Well, instead of me trying to find that, let me see if there's anything right off. Did I? I may have had something selected when I did that. Let's try one more time. Nope, it's saying there's a dash in here. So it created syntax. Yeah, I'm gonna have to figure out what that is. I'd have to correct it, but I don't see a dash in the first part. Let's go ahead and just run this part, see what happens. All right, that worked. Now let's run this part. All right, that one worked. And run this part. So somewhere in here. Cell small. These are the only places that has dashes in it. Oh, right here. Let's put some square brackets around it. That's probably it right there. And that was my fault. Because let me see if it works first. Yeah, that was my fault. Because it had a special character in it, it had to have square brackets wrapped around it. All right, so that's a good lesson to learn. I tried to follow the same naming convention here, but without realizing that I introduced a special character and it should be in square brackets. All right, so where did that go? What does it look like? Well, let's look back over under Workspace. Let's see. Come on, refresh. There. Oh, refresh it from here. Also, let me cancel this. I want to save this. Cancel. Give it a name. Create external table. SQL script. And we'll publish it. Just so we have a record of what was created. We don't really have to create it again. And it should be in a database called SQL Demo. And the reason I did that is I wanted to refresh this, and if I hadn't refreshed it, I could have lost it. So now I'm going to refresh it. And there we have it. There's SQL Database, there's SQL Demo, and there it is. There's our external table that describes the data over in my data lake. But notice it's external. There are no internal tables in a serverless SQL pool. So that's where it's going to be kept within the definition will be kept, the metadata will be kept in the serverless SQL pool, whether it's running or not, the definition is kept. And then the real data is over here under following that path. So again, if we go back into, here's that path, and here's where the data actually exists. Now, where did my script go? Well, if I go down here to develop, there it is. You can keep track of all your SQL scripts right here under develop, because that is going to be the repository of code that you might want to keep. Now, bringing up repository may remind you that you may want to keep this in a separate external repository too, like a Git repository, whether it's Azure DevOps or GitHub or GitLab. This is source data that could be kept outside of your studio. Okay, so let's go back to where we were, and just to show you where we started. We started out with linked, and we were looking at the data lake, and then I right-clicked to run a query without a database, and then I created an external table in a database, and that would be available, the script for that would be available under the develop hub. All right, let's continue with our slides. Go back. Here's a screenshot of what I just did. By right-clicking on the name of the external file or folder in your data lake, you can generate a query. By default, it's select top 100, but you could change that syntax if you wanted. But it's using the open row set function to access the data in a full path, the URL, to that very specific location in the data lake. Now, the steps that we let it perform to create that external data source is going to be shown here in SQL code so that you could do it manually. So we're going to create the database, as you see here, whatever you want to name your database, as you saw with mine too. If you got special characters, be sure to use the square brackets. And this will be for either serverless or dedicated SQL pools. You can do the same thing. But if you create a database in a dedicated SQL pool, you can also put data in it. If it's serverless, though, you can only describe the external data. So the metadata that we're going to see here does not define storage at all. And that's why you can use them in both cases, serverless versus dedicated. If you need to have this database populated with data from storage account, and you're going to run this maybe at a different time or load it periodically with a scheduled jobs, then you need to use a credential. In this example, it's using a shared access signature that the storage account would accept. So you would have to know what type of credential is needed in order to connect to the data lake. It could either be an access key, or it could be a shared access signature, or it even could be a managed identity. This is completely up to how you want to authenticate the SQL pool to connect over to your storage account. We did not have to do that in my demo because we're running under my account and I created both. You also have to define the external data source. Where is the data? This would have to point to a storage account, and also indicate what credentials will be needed. Notice here, SQL on demand is the name of a credential, a set of credentials that are in the second block, and they're being used now to connect to this location. Then what is its format? What does it look like? In this case, it's delimited text. In my demo, I used Parquet. So here's another example of how you could use a different file. Maybe you have a legacy system that can only generate comma-separated values, such as coming off an really old mainframe system or some other type of system that can generate these automatically, or you're simply dumping an Excel spreadsheet as a CSV file. It can be read with this exact format. And then finally, the last step is to create the external table that uses that format for that source with that credential. And now you've got a permanent object in your database that describes the external files. So as shown in that previous slide, you have to decide on how the user, yourself and others, are going to be given permission eventually for using your SQL pool, whether it's serverless or dedicated. Synapse Analytics comes with two types of authentication. The good old SQL authentication that's been in SQL Server for quite a while, or the newer Azure AD authentication that's very similar to Windows Active Directory authentication on-prem. These are Azure AD accounts in the cloud. So are you going to have to create new logins for every potential user, or are you going to use the existing Azure AD accounts that already are in the cloud? The second option would be a better choice, because you also wouldn't have to pass any secrets in an Azure AD authentication. You would with SQL authentication. But how is the pool going to connect to your data lake? That's another question. In our previous slide, we used shared access signatures. Now you could use anonymous access if you're going to read it and only read it, because anonymous access does allow reads without any authentication at all. But is that dangerous? Is there any sensitive data in there that anyone could have access to? So anonymous is not usually a good choice. Shared access signatures are sometimes a good choice, but only for a limited time. Shared access signatures also, you have to be careful that they could be intercepted and used by someone else, because there's no identity associated with a shared access signature. The last two are the better choice. Either have a managed identity associated with your Synapse Analytics environment, or have a user identity where the user passes their credentials all the way through Synapse Analytics as Azure AD authentication, and then it may use the same identity all the way through to the data lake. That's the better approach, because you're going to be using accounts that already exist. You just simply need to set up the role associated with that user. And that's done through RBAC, or role-based access control. The user, Tom, myself, if I need to access the storage account, I need a role. So I would either will be a storage blob data reader, or a contributor, or an owner, and each of those levels, of course, give me more permissions. When you're trying to just retrieve the data, as we saw in our previous demo, then all you need is a reader role. So by assigning me the storage blob data reader role, I'll be able to read my storage account in the data lake. Now notice this is regardless of whether I'm going through Synapse Analytics or not. So remember, there are specific roles already established for the storage account, and the data lake is works with the role assignment of storage blob data reader. You can also go through your storage account, as I was demonstrating earlier. Notice these steps here. You go into the Storage Explorer feature. Now, it is currently in preview, but it works. So it's something to keep in mind. They may change the interface later. You expand the containers, like I was showing you. I navigated into WWIO2, cell small, down to a year, a quarter, a month, etc. But at any level, I could right-click on that folder or level and choose Manage Access. And then I could manage, in fact, that's been relabeled to Manage ACL, Access Control List. And then you can add in a principal, which could be a user, a storage, a group account, managed account, or managed identity, and allow access to your storage. Or it could be done at the very top level. You could just simply say that a particular user is a reader for the entire account. Now, much of what we just covered applies, especially security, applies to other areas like the Apache pools, these serverless Apache pools. But why do we have a second type of serverless pool? Well, there's a lot of good reasons to go this route, especially if you've been using Spark in the past, you've been using Databricks, you can continue to use the same notebooks that you may have created elsewhere directly within serverless Apache pools. Again, like SQL pools, these are serverless, so they have no storage. This is just offering an alternative to working with SQL syntax. Now, this is not a Microsoft product. Microsoft is hosting this as platform as a service as Apache Spark Pools. These leverage the Apache Spark framework and a lot of the components that are part of the Spark environment, such as you see here Spark SQL. Now, that almost sounds contradictory what I just said. This is not T-SQL. The other one is Microsoft's T-SQL syntax. This is Apache Spark SQL syntax. Plus, you also have machine learning built in. Plus, you also have GraphX for graph computing. This relies on a completely different engine called the Spark Core Engine. And the Spark Core Engine is part of Apache Spark. It is a distributed execution engine that will allow you to work across multiple nodes. Again, another cluster. So a serverless SQL pool is a cluster of machines that work with SQL and SQL only. When you move over to an Apache Spark serverless pool, we're now working with the functionality and the features available through Spark. And Microsoft will continue to upgrade Spark based on whatever the current release is. And notice right below that, under the Spark Core Engine, we have something called Yarn. Yarn is kind of a comical name. It's yet another resource negotiator, is what it stands for. It's an acronym, but basically it's just become a word. And it lets you negotiate resources outside of Spark. And what resources do we need? We need storage. So the same way that your serverless SQL pools work with the data lake, same thing here. Your Synapse, Apache Spark serverless pools can work with exactly the same data as your SQL pools. Without replication, they're exactly the same. They're all external to the pool itself. So here's how it works behind Spark. We have what's called the Spark Context, which is a driver program that communicates to the cluster manager, which is here is where Yarn is, the Apache Hadoop Yarn. It is accessing multiple nodes. Nodes would be individual virtual machines. Each node has multiple executors on it. These executors run your application, whatever code you're sending it, in order to access the file system behind the scenes, which is the data lake. So this is very specific to Apache Spark. Conceptually, it's similar to the SQL pools as well. There has to be something that distributes the request across multiple nodes. So this is yet another cluster using a completely different approach, but similar behavior. Why do we need both? Well, you're going to see in a moment, it's the notebooks that can give you a lot of flexibility. So here we see to set up a Spark pool, it does have to be done manually. There is no Spark pool created automatically, like the SQL pool. The one that was labeled built in before was a SQL pool, serverless, that was started automatically or created automatically. Just like that serverless SQL pool, this will only contain metadata. This Spark pool has no charges until you use it. There's no resources consumed or created until you actually use it. So they don't cost anything. So these are really sitting idle, waiting for you to give it something to do, and it can take a few minutes for it to spin up. So here's an example that if you do want a Spark pool, give it a name, give it a node size. Now a node size, I would recommend that whatever node size you pick is also part of the name, so it's easy for you to see. Because you could have multiple pools for different purposes. They could be optimized for different things, they could be different sizes, so that you can keep your costs low or your power high when you need it. The number of nodes is up to you. In this case, there's 27 nodes. You can see it can go quite high, that it could have that many nodes ready to run. And pay close attention to the price, because the price will kick in once you execute something with that pool. So these can be created directly within the Develop Hub in order to create notebooks. And then you can choose the language. The languages here that are supported within Synapse are Python through PySpark, or Scala, which is Spark, C#, or Spark SQL, which is a specific type of SQL syntax for Spark. Not exactly the same as T-SQL, but probably 80, maybe as much as 90% overlap. These notebooks can be created from scratch, but as noted here, you can bring in one from the Knowledge Center. So let's go out and create one. I'm going to go out to the Manage Hub. Right here at the top, you'll notice we have the SQL pools. We have the built-in SQL pool. And if I go to Apache Spark, there is no pool. So I'm going to create one. And I'm going to call this one Demo Spark. Does not need to be isolated, memory optimized, and I'll make it small, enabled, and we can say it's up to 18 nodes. So between 166 and 994, that's $1 up. That very small, and that is per hour. Keep that in mind. That many of the pricing that you're going to see here is per hour. Dynamically allocate executors. That's not that important. Now, when you get into higher size or higher volume, some of these other options will matter quite a bit. Additional settings, we do want it to pause itself after 15 minutes idle, or I could say, let's make it 5 minutes. Make sure I keep the charges way down. And then you can choose what version of Spark you want to use. And this will change over time. And it'll also let you know what version of Python, Scala, Java, .NET is running or available to you inside of this particular pool in order to run your notebooks. We could give it a configuration file, session level. No, don't need any of that. And review and create. And create. So I'm going to create an Apache Spark pool, and then we're going to run a notebook on it. If I go back to SQL pools, should see a serverless, another one built in here, but I don't see it yet. There it is, Demo Spark. And if I go into it, not ready yet. Here we go. Let's try it now. Says it was deployed. it's ready, called Demo Spark. And notice too, over here, I can change its scaling settings. I can pause it. That's this double line, which is like a pause icon on a player. And then I have other options here. Like, of course, like I could delete it entirely. So my Spark pool is ready to go. All right, so now let's go back to develop. And remember, under develop, where we had our SQL scripts, I also could create a notebook. So if I go into notebook, I can create a notebook, but whatever name I want to call it. I'll call it notebook demo. And notice right now I'm ready to start typing. Notice up at the top, it defaults to Spark, a Python, PySpark for Python. I could choose Scala, I could choose C#, I could use SQL. But that's only the default for the whole notebook. Every cell could have a different language. So I could mix the languages in the same notebook, or I could have one notebook be all of one language. Now, as I said too, you could go to the gallery. So I'm going to add in another notebook from the gallery. Notice up here at the top, we have galleries for many different things. We'll see later on one for SQL script. And let's see, here's one, charting, to get you an idea of how charting works. I'm going to bring in that particular notebook that already has all the code in it. Open this notebook. And then before I can run it, notice it's got me a few samples of what you might see. These are not real charts yet, these are just demo charts. And here is the actual Python code to bring in data. It's not reading any data from a data lake, it's just hard coding the data directly within here. Before I can run the notebook though, I have to choose a Spark pool because this is Spark code. I can't run it on a SQL pool, it has to be on a Spark pool. So I choose that one. And I could say run all, or I could simply run one at a time. Notice this little run button, run cell next to this block of code. If I click run, it's going to tell me that it is starting right down at the bottom, starting an Apache Spark session. Now that's when it tells the pool, hey, I need you, wake up. So now we have to wait on that set of nodes to spin up, to get ready to run. And so the very first cell is going to take longer because it wasn't running. It was ready to run, but it was not running and not charging me anything. But now it will. As soon as I kick off this code, it's going to spin up the cluster of machines running Spark, and it's going to run only this first cell and take a few, it may take a couple of minutes to actually get up to speed and execute this very simple code. And you'll notice though, it's using something called PyPlot. So it's a mathplot library .pyplot. And so every reference to PLT starting with line 8, 9, 10 is going to draw a line using the X, Y coordinates above it. So it's going to be a very simple graph. You'll see it in just a moment. And we'll start, then we can run the rest of the cells more quickly because they'll have the servers ready to go. So you don't really have to choose between SQL versus Spark. You can have them both at any time and keep them running. You just have to run SQL workloads on a SQL pool and run your Spark workloads on a Spark pool. And they both can access the exact same data. Now, if it's pretty straightforward SQL, you could use Spark SQL and only use the Spark pools. But if you're very comfortable with T-SQL and Microsoft's original, all the SQL techniques within SQL Server and Azure SQL, then you may want to use the SQL Serverless pool. But eventually, you're probably going to want to use the dedicated SQL pool as the final storage of all your golden data, your aggregated data, so that you can have a data warehouse for reporting. All right, so I'm going to let that run a little bit. I was thinking 2 minutes might be enough, but it's taking a little bit longer to spin up those machines. And the only thing we're waiting on is really for the virtual machines to spin up. Running Linux, running Apache Spark, nothing to do with Windows or Microsoft products here at all. The only thing we're using that's Microsoft is the cloud service, Azure cloud service. All right, so I'm gonna let that keep running. We'll come back to it in just a minute. What we're gonna see is different cells, and you'll notice here we have generate data while executing the command. You can generate data on the fly, or notice the second example is we can load data using spark.read. Both of these will create what's called a data frame. Creating a data frame is an in-memory construct within your code that gets distributed back across all the nodes. So the data frame can be used from one cell to the next because you're still using the same pool, the same nodes, and so you can even switch language without having to switch the data frame. So that's a powerful feature too. The language is just continuing to use the same nodes as well as the same parameters and the same data frame values as you see here. So you can load data from Blob Storage, your data lake, a SQL pool, and have it in a data frame itself. In a very similar way that we saw with SQL pools, you can work with the same data with Spark pools. You can also read from a pool and write it to a dedicated SQL pool to store the data permanently. Now this is specific to Synapse Analytics. You'll notice in the second block here, the last line says df.write.SQL Analytics. That is a specific extra feature built into SQL Analytics that you would not find in Databricks or Spark itself, but this is allowing you to work within this environment and write out data to a SQL pool for permanent storage. So you can move data with Apache Spark right from your data lake and read it from there and write it out to a dedicated SQL pool. You can also reverse it. I can read SQL Analytics, read a table out of my data warehouse and write it back out to my Spark pool as a data frame and then write it anywhere else I want. So notebooks are very flexible. You may find them much more useful than just SQL by itself because you can switch languages, you can work with multiple stores, reading and writing, and we also have this built-in capability to work with a dedicated SQL pool within the same code. See if it worked. Yeah, it did work. So notice it created this plot, and if I go down here and run the next one, it's going to run much faster because the servers are listening. I go down here, let's try another one. That one's going to take a few seconds. There we go. That's a real plot based on this data up here, random values. All right, then we are using another pie plot here. Run it. It's going to build a scatter plot. Notice this down here is just an example. So if I run stack plots, I get the data here. Pie charts, field line charts, multiple line charts you see for different values. And these are all random. So randoms are a good example of two, there we go, different charts altogether. 3D scatter plots. This is all being done within Python. So you can start to see, if you don't know Python, now's the time to learn it, particularly the Spark version of Python, so that you can represent your data with very useful and interesting graphics directly within your notebook. Here's another one. So we've got quite a few examples here. So it's called charting in Synapse Notebook, and that's in your gallery. I did not have to write any of this, and all these are different examples of code that you could leverage yourself. Pretty cool stuff. All right, now Let's look at dedicated SQL pools. Just noticed I misspelled that. Let me fix that real quick. Not dedicate SQL pools, but dedicated SQL pools. Oh, get back to that. So dedicated SQL pools include storage. Now let's compare them a little bit more closely now as far as the architecture. We've already covered what's on the right. That is serverless SQL pools and how it relies on a control node to work with compute nodes. But notice the difference between these. The dedicated SQL pool has an extra little character down there or icon called DMS. DMS stands for Data Movement Service. The data movement service is for distributing the data across multiple compute nodes in a massive parallel processing environment. So this massive parallel processing engine is going to manage the distribution of the data for both reading and writing across multiple compute nodes, all running SQL. Keep in mind too that it also could be leveraging the data lake for external data. So it supports both, whereas the serverless SQL pool only supports the data lake, the Azure Storage Data Lake services. So DMS is the big difference here, using a distributed form called Data Movement Service, a distributed database. So the control node is going to be aware of the different compute nodes where it's going to act on the data as well as to store the data. Notice this animation. We've got data coming in. The control node gets distributed out to multiple computers, multiple compute nodes, and then the data is returned as it's read. So we want to make sure that we distribute the node appropriately. And we're going to see how you can do that with 3 different mechanisms of how to distribute the data, depending on how you know the data will be used. So when the data is split up, it's called a distribution. And a distribution is a basic unit of storage and processing for parallel queries. And they run on the distributed data. We can either have the data spread out evenly, we could have it organized by a hash value, or we could put all the data of one data set in the same data on all nodes. That's up to you. The same slide we saw before for serverless can also be done for dedicated. Remember this? Create a database, create the credentials, create the data source, create a file format, and create an external table. That is how you work with a data lake in both SQL pools. But the big difference with dedicated is that we can also create tables, not just external tables, but we can create tables inside the dedicated SQL pool. And then we can use these 3 basic methods. Now, there are some older methods that you could use, but we won't cover those here. We're only going to cover the most recent. These are the best practices. You can use Polybase to retrieve the data and store the data inside your dedicated SQL pool. You could use the copy command to copy data into your production tables or into a staging table and then into production tables. Or you could use a pipeline and use a copy data activity. Once you have done the previous steps we saw before of defining the metadata, here's how you could load the data with SQL code. Now you're going to find, this gives you the most control, but it's not necessarily the easiest way to do it. We're going to see the other 2 are much easier. But here's how you can do it through code. Create a login within your SQL database. The user grant control of what's called static RC20, which is just a static resource class. And then step 4 is where you actually define the storage area. Create table, not external table, but create table. Now I just made up a table with only a single value, no 2 values in it. And notice the distribution, that's an important part. Distribution round robin just means put an even number of records on every node. Like record 1 goes here, record 2 goes there, record 3 goes somewhere else. and just keep spreading it out, just like you're dealing cards, you know, in a card game. Round robin just means we're going to go round and round, giving everyone the same number of rows. And it is a clustered column store index, not just a standard relational type database, but a clustered column store index. So everything is stored by columns and not by rows. And then step 5 is the work, copy. So the copy statement is going to copy into this new table from, notice the path, a data lake, and in this case it's a CSV file, field terminator, etc. So the data is going to be loaded into this. So since it's only got 2 values, we expect the CSV to only have a number, comma number on every row for this to work. And that's how you can copy using polybase. So you never use the word polybase, but behind the scenes, it's leveraging polybase to convert the data lake files into SQL-like structures to return a result set. Now, an easier way is to let the studio do all the work. You can navigate to the same file like I did earlier. Remember, there was an option there for bulk load. So new SQL script, bulk load, and then when you use bulk load, it's going to allow you to preview the data, create a script, and then once you run the script, the last image you see on the right is what you would expect within your SQL database. It's not an external table. It's a table that contains data. So this climate daily CSV file you see in the screenshot would be loaded into a newly structured table, whatever is in it, whatever definition or schema is associated with it. So in the slide that you're seeing, hopefully, you also see the transcript at the bottom of the screen. I just realized that was probably not being shown either, the first half, and I apologize for that. Hopefully this is recorded. Even if it is recorded, though, you'll only see the same thing that I was showing earlier, but hopefully you'll have time to go back through and maybe go through the same steps again. All right, so one of the basic services of working with Synapse is you need data. You need to store the data somewhere. And across all services, the most common and fundamental service is storage accounts within Azure. Now, the storage accounts originally only had blob storage. Then, with one new feature added that you see highlighted in this slide, is we could enable the hierarchical namespace. By simply enabling the hierarchical namespace, you create a data lake. And so that's exactly what I had. So let's go back to the portal, and also something you should have been able to see all along. Here is the Azure Portal. And in my storage accounts, I had the storage account created earlier as a data lake. So it clearly labels it here, and it's only because the hierarchical namespace is enabled. This is a feature that cannot be changed after it's created. So whenever you first create the storage account, you have to decide at that moment whether it's going to be the original blob storage or a data lake storage, which has hierarchical namespaces. Now that word, hierarchical namespace, really just implies that you're going to see folders and directories within every container. But in addition to that, it's also going to be Hadoop compatible. So that means it's been designed to work with Hadoop, and that is Apache Hadoop. So before we had Spark, we had Hadoop. It is a file-based data analytical tool that you can use to map and reduce data to make it reusable through your data processing stages. But with the advent of Spark, Hadoop has kind of fallen to the background because Spark is taking it to the next level. In fact, the features within Spark are following a second version, or the second evolution wave of what Hadoop became, and it becomes more memory-based. So when you use a data lake store, you are creating a storage structure that would work with Hadoop and Spark. Now, there's no extra costs for turning on the hierarchical namespace right now. It's either one or the other, but right now the pricing is the same for either one. The security is the same too with Azure AD between either one, but because it becomes Hadoop compatible and it introduces multiple folders, it also introduces ACLs, access control lists. We can also increase the performance, and it also has built-in redundancy, mainly on how you set up the pricing tier of the storage account. So the performance and the redundancy are applied no matter whether you have a data lake or not. It's part of the storage account functionality. The basic structure, as you see in these slides, are obvious, is that if you're working with the original Blob store, you are working with a very flat namespace. There are only lateral containers with no depth. There's no folders within a Blob container. But with the data lake, and particularly what they refer to as Generation 2, we have hierarchical namespaces or folders within folders, and we also have the Hadoop functionality, so it works very well with Spark. In addition to the data lake storage service, we also have something called Delta Lake. Now, Delta Lake is a layer on top of your storage service that introduces the support for transactions that you may have been using with other types of stores like a SQL database. It introduces the atomicity, consistency, isolation, and durability functionality that we normally associate with the ACID acronym, ACID. That allows us to version every change, and we can roll back or undo certain changes and also look at the history. This is where I mentioned earlier that the data can go through different stages labeled as bronze, silver, and gold. Now keep in mind that Delta Lake is a format. It is not a service, but it is included, support for it is included with Synapse Analytics. You organize the data lake so that it can work with this concept of multiple stages, bronze, silver, gold, and you organize your data into layers or folders that correspond to how you want to move the data through each of these different stages. You ingest the data, so the raw data comes in labeled as bronze, then you refine it, you fix it, correct it, add to whatever, becomes silver, and then you may filter it further, transform it further, but usually aggregate it in order for it to become gold and could be eventually moved into, say, the data warehouse, or it could be kept right here in gold. So it's a way of formatting the data and introducing transactions that allow you to work with committing and rolling back changes and keeping a history of the data as it moves through these stages. The Delta Lake is not required, but it's an excellent way to keep control over the state of the data, especially if you're dealing with a lot of streaming or a massive amount of batch data, as you see here on the far left. And then ultimately, once it's in the gold state, it can move into another tool or service for analytics or even machine learning. Which brings us to another storage service that is built in now within Azure Cosmos DB. This is called HTAP. Cosmos DB, HTAP, is hyper-transactional analytical processing, which is a feature that needs to be enabled. It's a checkbox, really, to say I need to start aggregating the data into an analytical form instead of just in a transactional form. What does that mean? Well, here's a simple diagram to show you how that works. So what you see is the data coming in from the left, we refer to as operational data. Where it comes from, it could be coming from an application directly, it could be coming out of a data lake, and it's simply written into Cosmos DB. So normally it would be data maybe that's written from an application, a website, or some other process, and it comes in as transactional, which means it's row-based. It's a row store that's designed for very quick reads and writes, not for aggregation though. But if you enable the analytical store, then it will automatically synchronize to a different type of store and become a column store that would be ideal for analytical queries and reporting. This is all going on within Cosmos DB. Nothing to do with Synapse Analytics yet. But once this has been done in Cosmos DB, then Synapse Analytics could establish a link through Synapse Link so they can access the column store data as if it's part of your pool, your SQL pool. So here's another example. Instead of just depending on the data lake, you could also access data within Cosmos DB. Near real-time business intelligence and analytics and machine learning could happen now because of pulling the data in through the Azure Synapse link. Now, that does not mean it has to be stored into Synapse Analytics at all, but it could be. Notice that it could be used for machine learning, other analytics, building dashboards, or simply building a warehouse with data coming from that analytical column store. The reason you don't necessarily need to move it is that because that analytical store has no impact on the transactional store. Your mission critical apps, your business apps that are collecting data and writing it to the transactional store will not even notice what's going on with the analytical store. The auto sync runs in the background and will take the data coming from transactional and build a column store automatically. Now this is called Azure Synapse Link without the word Cosmos DB in the link because Microsoft is looking to apply this to other types of stores, such as a relational SQL type store. So be prepared to see how this may work with other services, but they introduced it first with Cosmos DB. All right, just to make sure that I'm sorry it was so frustrating the first hour and a half, can you see this slide as well as my screen when I'm showing the portal? If you could just post something in the question, or if you have any questions too, feel free to post them. I can see your questions now. Now the other thing that you obviously couldn't see before is when I was navigated to the studio. In Azure Portal, WSJTK just happens to be the name of my workspace. Once I created it, I was able to access the workspace web URL or simply click open under Open Synapse Studio. Either one of these will take us to the studio. Under here we had the different hubs. We had the data hub, develop hub, integrate, and then we have the, I'll expand these out, you can see them, monitor and manage. So what we did before is that I pointed out that the built-in SQL pool is serverless, so it has no storage. I also created an Apache Spark pool called Demo Spark, where I was able to run the notebooks. So you were not, oh, that's unfortunate, you were not able to see the results of the notebook. All right, so I will keep checking on that. All right. Go back to the slides then. Any questions, please post it here if you can. Yeah, you were watching the notes. Yeah, I see that back, 244. I am very sorry about that. All right, let's move on. The switch that you need to turn on in Azure Cosmos DB is simply this. It's a feature within the account called Azure Synapse Link. Let me show you where that is. I'll go back to the portal. And in the portal, that means we have to have a Cosmos DB account. Now, a Cosmos DB account is a NoSQL type store. It has 5 different APIs. And when you create a new Cosmos DB account, you have to choose between those 5. There's core SQL. Now, the word SQL is misleading. It is not a SQL relational database. It only supports the SQL query language. So select statements work, but core is actually JSON documents. We also have the Azure table. Now tables here are more powerful than the storage account tables. If you've been using those under storage accounts, you can use the Azure table in Cosmos DB. They're much faster. Every attribute is indexed, and you can replicate this multiple times around the world. You also have support for the other three that are open source databases, MongoDB, Gremlin, and Cassandra. So let's just start with a simple core, Cosmos DB. I'm going to put it into a resource group. I'm going to put my name on here, or initials, Cosmos DB, and then I'll put core on the end. I'll put it in the East US. Provision throughput, no need to apply free, no need to limit it. And I could turn on global distribution, but that takes a little bit longer, and we can do that later. But I can pick other places in the world to replicate the data and turn on multi-region writes, etc. And then we can replicate the data multiple times. No matter which API we choose, we have that same functionality. So we'll review and create. All right, so this should take about 2 or 3 minutes. Double check, and create. Now, once it has been created, is when we can enable that link feature. Again, under the settings features, Azure Synapse link by default is turned off, so it's not building that columnar store until we enable it. And that's a good thing. If I'm not using Synapse Analytics anyway, there's no need to turn it on. But once you enable it, it becomes a connection point for Synapse as a hybrid transactional or analytical processing connection, or the HTAP. Okay, we'll let that run. And, let's continue with the slides just for the concepts here. Once we build a container inside Cosmos DB, now a container is very much like a table or a graph within any of these others concepts. So the word container, table, graph are all synonymous. It just depends on which API you use as to how that term is used. So with a single container, notice down at the bottom, we can turn it on or off within each container. So we do have to turn it on for the whole service if there's any one container that may use it, but it doesn't turn it on for every container. So this is like a sub switch. We turn on the main switch, but then we have to go into each of the containers and say whether they're going to use that feature or not, so that Synapse Analytics can connect to this table or this container. So I am going to create one of those in just a moment. Let's go back to, yep, there it is, it's ready. So if I go into my Cosmos DB, drop down to features, here we have one of the new features, Azure Synapse Link. There's several others here. Go ahead and select that and enable it. So that's going to turn on the possibility that a container can be the source of a columnar store. So now that it's pending, we have to wait for it to create really the basis for it. And then while it's working on that, I can go in and create a particular container itself. So notice this is my Cosmos DB core, which means I'm working with only one API. And if I add a container, first thing it's going to ask for is, wait a minute, what database do you want to put this in? So I'm going to call this one HR. I'm going to keep up with employees. And the container ID down here is going to be employees, or my employee container. Notice something else here. We've got RUs. Now RUs is a normalized unit of measure, request units. How fast do you want it to be? Correlates to how much are you willing to pay. So the whole database could have a certain number of RUs that can be adjusted at any time after we created it, or several months from now or whatever. What are you willing to pay for the speed of this one database? And what's really nice too is that each container can have its own speed, different RU settings. Now, if I'm going to keep up with employees, I also have to decide, well, what partition are you going to be basing this on? So I can divide up my employees by department, which behind the scenes is going to distribute the data across multiple resources to keep track of this in a partition, a logical partition database, which may spin up other machines in the background. But again, like our cluster, we're not in direct control of those machines. So the physical partitions are going to be automatically handled for us across multiple resources. And then here we have it. There's that option to turn on the analytical store. Since it's not activated, that means I know that the service is still not fully provisioned yet. So I'll go ahead and try it again from here, because I could turn it on from here. Oh, don't touch that. I think I just aborted my new table. Hold on. Yep, I did. I have to put it back in again. HR employee. My partitioning is the department. Oh, now I can do it. All right. So now that I've turned that on, as soon as data starts coming into this Cosmos DB account as JSON documents, they will be rebuilt in an analytical store and made available to Synapse Analytics to read it live. So this is going to build the container. Now, it actually has to do two things. It's building a database first, then it's building a container called employees, and then I can see it right up here. I can navigate directly to my employees. I can go into all the individual employees, and just for a test, I can add a new item. Now this is all JSON, so I have to be familiar with JSON syntax. That's going to be maybe their employee ID, their last, oops, got to quote, expecting that to do it for me, last name, colon, and values. I'll just put myself in, comma, first name, colon, time. All right, and that's all I want. And I'll save it. So I created a document in JSON and actually left off the department. But notice there's other system assigned values such as row ID and timestamp as part of this API. So this was sent into Cosmos DB as a request. It came back and acknowledged that yes, we were able to save that as an item in your container. That very same data now is being automatically auto-synced over into a different type of internal store. And it is column-based and can be used directly by Synapse Analytics. Only because I turned on that feature, so that feature of Azure Synapse Link is turned on, and that container Explore, and that container automatically had it turned on as well. And each of these, here we go, the settings. Yep. Oh, we also have time to live. If we want it to be a very limited amount of time, we could turn that on. So this is really is not even been set yet, but we could say it only lasts a certain period of time, and it will rebuild it again later. So basically reprocessing it. All right, so that is a feature that has been added to Cosmos DB. So when we're over here in our studio and I'm looking at data, I could link out to connect to external data. And notice right here, I can connect to Cosmos DB, core, continue. And let's see, yeah, all subscriptions, there it is. And there's my HR database. So I can connect to it and pull that data into my data processing within Synapse Analytics as a new linked service. Cosmos DB, and that should be it. I could add some annotations to it, some other connection properties, but I am now linking that into my studio so that I could read the data coming from it if I had a system that's loading data or working with data within a Cosmos DB account. So now I have a bridge or a link over to Azure. Now, this particular feature is not available in every location around the world. This is a limited deployment, but most of it is in the United States and some of the bigger locations in Europe, North Europe, West Europe, etc. Let's see, linked. Oh, let's see, got Synapse Live. Nope. Okay, let me refresh this again. Be careful when you refresh that you have saved what you may have done, because sometimes it does take refreshing the browser to see this. So there we go. I've got a link for my data lake, and I've also got a link for Cosmos DB within Synapse Analytics. All right, question, is the cost of the analytical store included in Cosmos DB pricing? Yes, because the data is kept in Cosmos DB. It's not moved over to Synapse Analytics. Now, we can query Cosmos DB with Spark within a notebook. We're going to see several examples of here of how to do that. But once you have it connected, notice in this screenshot, number one is the data is loaded into a data frame. Now, a data frame, remember, is a distributed logical data concept inside Spark, which points to the data as it's being kept across multiple nodes, multiple computers in memory. Remember, these are serverless inside Synapse Analytics. There's no storage. So Cosmos DB is acting as the storage. Spark is being used for analytics, and it will load it into a memory-based data frame distributed across multiple nodes. Clean up the data frame, in other words, clean up whatever data we just pulled in. Do we really need all the attributes? Do we need all the data? We also, since it's coming in from core, it's going to come in as a JSON hierarchical structure. So step 3 is we need a way to flatten it out so that we have rows within columns of data instead of a hierarchical document. And then we create the final data frame that we can act on inside Spark. And then we may write it somewhere else. As you see here, it could be written out, whatever you might want to output. They don't really show it. They're working with SQL here, but that's basically when they're flattening it out, they're making it look like a SQL result set. But it doesn't necessarily mean you're storing it permanently anywhere. So let's see an example of each one of these. Step 1, load the data into a data frame. Use df equals spark.read, and that's your most typical way of reading data into a data frame. df acting as your data frame. Notice the format. It's using Cosmos OLAP. OLAP stands for Online Analytical Processing, and that is typically an analytical store that's column-based. So that's just the name that is used to go out to a known structure in Cosmos DB. The options that you see here are saying that we want to link to a particular link service that's already been defined. In this case, it's the database. And then the second option would be the container. And then the last step is to load it. So spark.read.load is going to load it into the data frame. So our DF now holds the raw data coming from that container, which can be quite complex and have multiple layers in it, a hierarchy of attributes. Next thing is we want to clean up the data frame. So notice here is some examples of code where we're going to identify what we want and what we don't want. So notice they want to take out the row ID, the timestamp, those extra system values that I showed you that we really don't need. We just want the raw data and maybe not even all of that. So notice it says we want the list, the df columns minus the unwanted columns to return only the columns, and then df.select those columns. Now, if you knew the columns you wanted, you wouldn't have to really do lines 1 and 4. You could just say these are the columns that I need, and then basically it's showing you how to just display it. So profiles is going to be a new data frame, and here we just say I want to be able to display up to 10 of them. Now the reason what they're pointing out here with the numbers is that these are going to be still complex types because they've got values nested in other values. So it's not flat. It's still a hierarchy. Even though we don't want all the other columns, there's still a nested set of nodes within nodes or elements within elements. So the next thing is we need to flatten it. So we have a method called, or a function called explode. Now that sounds just the opposite of flatten, but in order to flatten something out, we have to explode all the levels and bring them up to the same level. So that's what explode does. It returns a new row for each element of the matching arrays in this example. So notice what it says. It's going to go into profiles, and we're going to select user ID and explode the preferred products as product ID, and then we're going to go into product reviews and explode those out as product reviews for that user ID. So every product that the user has reviewed would be on separate rows in one result set. So instead of having two different groupings, we now are bringing the groups together into single rows of data. And then the last step is to create the final data frame. And in here we have something called preferred product reviews, and we're joining these into one list. So here's the user, the product, and the review, all the way across as a table. All of this is because this particular API that I used is based on JSON. Each API in Cosmos DB is a completely different structure and a different way of working with the data. So you'd have to know which API you're pulling the data from as to what you're going to do with it and how you're going to flatten it out. Now, some other, like the table API, and not every API works here, but the core definitely does, as you see in this example. What about with SQL? Well, notice here, you can do the same thing that we saw before in creating the metadata by using a view and the open row set. Remember that SQL uses the open row set so that you can query data without defining any metadata. So here we could create a view with open row set, and then notice the two with statements, with, and it's looking at preferred products and product reviews and doing a cross apply with open JSON. And again, because this is JSON and it's got a hierarchy in it, we're having to do all of this at once. Bring in the data, parse it, flatten it, and generate a result set. So this will create a view that will then be immediately available within your SQL environment to query Cosmos DB from now on. You don't have to go back through and create it multiple times. This is all because we now have Synapse link over to Cosmos DB without having to move the data at all. There's no extraction. There's no loading of the data into a dedicated instance. And so that will save your money because you don't even have to create a dedicated SQL pool just to work with Cosmos DB. You can continue with the serverless pools, both SQL and Spark. Now, let's get into the biggest area of this demonstration. And I'm really glad we got it worked out where you can see what I'm doing here. And we're going to look at building pipelines. A pipeline is just basically a series of activities. These activities must be leveraging services. So the very first thing you normally have to define are what are the link services that I will use in my pipeline. So pipelines are made up of activities. Activities use linked services for two purposes, either for storage, as you see here with a data lake, or for some other computing service, such as Databricks or something else. You have to establish your linked services, and then from the linked services, you also have to define the data set that is available within that, within your storage, whether it's a source or a destination. So the data set is going to represent the structure of the data as it's used within the pipeline. Very similar to a data frame that we saw in a notebook. So as the data comes in from these linked services, the activities will leverage the link service in order to at least pull data in, but transform the data, send it to some type of computing process if necessary, and then eventually create a sink or a destination. These activities are defined in a pipeline as a group of activities. The data will feed into one of the data-based, well, data source activities and be processed, but the pipeline is first triggered in order to act on the data store, process the data coming in, act on it, and eventually write it out to a destination. The entire time, of course, this is being defined within a data set. Other features that a pipeline can have associated with it are parameters, a specific runtime environment, an integration runtime, whether it's cloud only or on-premise, it can be both. And you also have a way to control the flow and design the flow as a pipeline. So all of this are the components of a pipeline. Now the pipeline was originally defined within the Azure Data Factory Service, or ADF. You can continue to use ADF, or you can use Azure Synapse pipelines. They're basically the same technology. It's just that pipelines in Synapse are included with the other services of Synapse. So the first thing you have to define are all the link services. A link service is available within your Manage Hub. So let me go back and look at that real quick. I'll show you. So the Manage Hub is our last hub here on the left. We go into link services, and link services could be created through other interfaces. As you already see here, we have a link out to a default SQL Server, a default storage. Both of these were created when this workspace was provisioned. And then I added in Cosmos DB. Now I could click New up here and then notice all these other options. I can even connect over to Amazon, AWS. We can have cloud-to-cloud linkage. We can connect to Blob Storage. Another big one is cognitive services, Microsoft's cognitive services that you can send content to and get results back. Like, tell me what's in this picture, or tell me, is this tweet from Twitter is positive or negative, or whatever. There's many different things you can do with cognitive services that are simply an API call. Notice the different Cosmos DB. We've got MongoDB as well as the core SQL API. We have a new database you're going to be seeing more and more called Data Explorer, which goes across a time-based database, which you use KQL or Kusto query language in order to query it. So you can scroll down through all of this. Every one of these could be a link out to services, including not just Azure services, but we see here HTTP or GitHub or any of these other services that we need to send or receive data from and send to get some type of response. We also can start working immediately with Power BI. So a link service is not just data. It could be a computing service, or it could be both. So each one of these have different parameters that need to be sent or connected with it. So we can follow through and work with any one of these. Probably the most likely one when you're first starting out and experimenting with it is probably Blob Storage. Now, this would be a different storage account than maybe the one we created for this workspace. So there could be 5 or 6 other, storage accounts that you might want to bring into Synapse Analytics. So again, a link service is your typical starting point to define all the pieces that you're going to leverage, data and computing services within your pipeline. Now, an integration data set is basically how do we define a data structure that we need to use within our pipeline. These are basically named views of data. Whoops, sorry. And these named views of data have to be tied to some type of link service so that we know where it's coming from or where something is going to. These can be created off of the data hub. And we can use these to say, I need to read, say, some type of entity in my source in order to infer the schema that I want to use as a data set within my pipeline. So hence the name integration. It helps you integrate the structure of data that you're going to use in the pipeline with either a source or a destination that you're ultimately going to write to. So it has to be in the right structure. So even though the integration data set, it does not know where the data is coming from or where it's going, it does define at least the structure, and it's the link service that you connect it to that defines where it actually is, where it's actually stored. Then you can create a pipeline. Now you actually can start with a pipeline and create the other two, but if you plan ahead, then you know you're going to need certain link services, you're going to need certain data set structures, or you can do it all when you get to this point. So let's go back into integrate now. Integrate has the icon of a pipeline. I can click the plus sign and choose the first option, which is create a pipeline. When we create a pipeline, and I'll call it demo pipeline here, we can start dragging different activities from our list here. And one of the most common ones is simply to copy the data. We saw that mentioned in a previous area. If I want to move data from the data lake into Synapse Analytics, this is an easy way to do it graphically. So I can drag over a copy data here. Or I might have a notebook. I might want to run a notebook before I copy the data, or I might want to run a notebook in any order. You'll notice too that there are handles that you can connect these two. And when you connect two different activities, it means the preceding activity needs to finish before the subsequent finishes, but only depending on this connection point between it. If the notebook succeeds, then we copy the data. Or if it fails, maybe the notebook didn't work, so let's try the copy data approach. Or you got 4 options. We don't care if it succeeds or not, it just finished, that's blue. Or if it was skipped, then we go ahead and run this one. Skipping may happen if a previous step fails and skips over this step. So those are the 4 colors to be aware of, no matter which activity you put in here and what order. So we got to delete that one. The most common probably is the one activity succeeded, so let's move on to the next. You may have a few red connections to handle exceptions or errors within your pipeline. So you have many of these areas. The very first one is one for connecting or integrating Spark. So we've got notebooks, jobs, SQL pools, stored procedures. Move and transform is simply copy or data flow. Now, data flow is a very rich environment where we're only working with rows of data, and most of your transformation could happen within the data flow. You could use notebooks only and no data flows, or data flows and no notebooks, or maybe throw in stored procedure, or all three. If you go down even further, you see that there are other areas like maybe bringing in a notebook from Databricks. So you're using a notebook over in Databricks and you'd like to reuse it again in this pipeline. Now this notebook is different from Synapse notebook because the Synapse notebook is running in Synapse and is not running in Databricks. So it has a slightly different set of capabilities. Or it could be jar, Python, for Java and Python processing. And then we also have HDInsight. We could use some of the Hadoop functionality, Hive, MapReduce, etc., under HDInsight. And then we have iterations and conditions, which is quite long. Oh no, it's not quite. No, general is the long one. Yeah, general is where I can work with variables, lookups, connect to webhooks, and then with conditions, I can also set up if, for each looping, switch, etc., to create an entire logical set of steps within your pipeline. And then once your pipeline is complete, you can publish it. Now, mine is incomplete, so if I try to validate it, it's going to pop up some properties that need to be set. In fact, yeah, there's not much in here. I don't even have a notebook set. Notice over here, copy data one. Well, every one of these are required, so they're all missing. And so that's very roughly a rough sketch of what a pipeline is. And then we can schedule it to run periodically, every day, whatever schedule you need as a job. So drag over an activity, set all the properties of that activity, and give it a good name so that when you look at the pipeline, you understand the steps that are being performed through these activities. You also have to decide on a runtime environment. So the integration runtime, or IR, that's indicated here, usually if you're only working in the cloud, is going to be the first one. So if everything is between two public data stores over the internet, then you simply just need Azure Integration Runtime. Even if you're working with Amazon, it's still cloud to cloud. Now, if you're going to work with on-premises, that would be what's called self-hosted integration runtime. And then there's actually a third, which is SSIS. If you've been using SQL Server Integration Services, it can now also be integrated with Synapse pipelines in Data Factory. At any time, too, the pipelines are being written in code, whether we're talking about the link services that the pipelines use or pipelines themselves. Underneath the covers, they're still being stored as JSON. So here's the declarative form of a link service, ASA data lake, the type, the properties, etc., defining in JSON in code. Now this is available through this little icon that has the braces. So by selecting the braces, you'll see the code of the particular component that you're looking at. The reason this is brought up is that even though you may design something visually, you're actually building code behind the scenes. And they too can be added to a repository and managed through DevOps. You also can use notebooks. As I indicated in our diagram here, we have the notebook, and down here below, we have the basic settings about the notebook. Which notebook is it going to come from? Which pool is it going to run on? So between the general and the settings here, you will define the notebook of what will be activated when this pipeline runs. And this is a notebook under Synapse, so it only needs this environment running in Synapse. If you choose a notebook from Databricks, for example, it will need to, or jar or Python, it will need to leverage Databricks. So Databricks needs to be ready to run because it's going to send a request to Databricks in order for it to act on maybe a notebook stored in Databricks. So really, it's really supporting notebooks natively and connecting to notebooks in Databricks, which also is running Spark. And they could have identical code, why not just move the notebook to Synapse and run it in one place? If you're going to use a notebook in a pipeline, you also might want to consider creating a cell as a parameter. So notice this says that you can toggle a cell as a parameter cell. In this example, basically they're wanting to override the run ID variable with a parameter. And by making this a parameter cell, then they can have a value come in by the pipeline. So it acts as a parameter for the pipeline so that you can control what content is being passed in to the notebook. If it's in a series of activities, a previous activity could have generated a new value that needs to be passed into this notebook, because now it's cooperating with a series of activities. And so the notebook needs to know, maybe from the externally, what type of data do we need to bring in at this point within this cell. So if we toggle the parameter, it's basically going to say, okay, you're going to have a run ID parameter. If the pipeline doesn't give it a value, it will be a UUID in this screenshot. And notice it does have a parameter label on it once you toggle it. So it'll be a clear indication that this is not just code that will execute as part of the notebook. This is a connection point for a pipeline to connect to the notebook. And let's see, yeah, they're using it right here. Oops, I got it. The run ID is part of the parameters, and then another step later on in the notebook, if it refers to run ID, if you looked at just the code, you might think it was a UUID, but that's the default. But if a parameter is coming in from the pipeline, then whatever they passed in will replace that value. Now we can add notebooks to pipelines in several different ways. You could be in the notebook working on it and then say, I need to attach it to a pipeline, or I need to create a new pipeline starting with this notebook. So there's a little integration icon of a pipe that you see in the screenshot. And you could say, I want to connect this notebook to an existing pipeline or create a brand new one from it. If it's existing, then on the right-hand side, you see that you choose the pipeline it needs to be put into. Now that doesn't mean it's going in the right place, but if you open up that pipeline, you could be able to rearrange the activities in the order that it needs to run in, if there's more than one activity. And as already demonstrated too, wherever you put the notebook in the flow of logic, you need to connect it to another activity. And these are those 4 settings. In this example, the notebook would be run only after the data flow is successful. So every activity has this capability of one being dependent on another. Now, if it does not have any type of connection, then they will start at the same time, asynchronously. So you want to be careful that if you did not intend to do that, that every activity needs to be connected to a preceding activity. In this case, the data flow will start first when the pipeline is triggered, and once the data flow is finished, then the notebook will run. So what is a data flow? Now, a data flow can be one of the most complex areas of development, because you have to determine what's going to happen to the data as it flows through this single activity. Now, a data flow is a single activity, but it may work with many different sources and create many destinations. The pipeline itself does not work with the data directly. It simply executes activities that may work with the data. So you may have a notebook that works with the data. You may have a SQL script that works with the data, and then you may also have a data flow. A data flow is built into Synapse, and it allows you to define a source and the transformations and the sink, or the destination. Here is a simple example of one where we start off with e-commerce user profiles. We maybe create or add something, create and updating columns with user ID, pulling in the user top products, and then write out to something for derived product columns. And that may be the end of the line. But notice at the same time, we could start another parallel transformation with another add source. But let's go back into our pipeline. Remember, we went from notebook to copy data, but if I bring over data flow, there is no data flow to pick from. So notice there's nothing to pick, so I'd have to click new. So I may want my data flow to be in here, let's just say after the copy data works. Now this is just showing how a flow might happen, but in order to define this data flow, I either need to click new here, or if I go up here to develop plus, there's a data flow here. Either way, this is going to create a data flow. Notice it starts off with a source. What are you going to read? Let me see, there's a question. Is there a version control of pipeline code? Well, that's where you need to introduce a repository. Very good question. And you can do that. You can introduce GitHub or Azure DevOps as part of your environment here. Very good question, because all of it is in JSON, and it all is basically code behind the scenes here. All right, so I'm going to add a source, and notice that I can add a source. Now, what's under preview is something called Flowlet. Flowlet is really part of a pipeline that's not fully available yet, but you'll be able to save different components or different combinations, little pipelines, you could say. Kind of wish they call it something like pipette or pipelet or whatever. Flowlet is in preview for that, so we won't look at that, but that'll let you create reusable sections of pipelines. So we're going to add a source, and notice down here it's going to give us the option. Okay, what do you want to call it? Source one is fine, and we have three options: an integration data set. Remember, that's just a structure of the schema of data being used within the pipeline. We have inline, and we also have Workspace DB. So in order to define the source, where do I get started? Where does this data come from? What is the data set? It also has to be defined. If you don't have one, you can click new here. And then you have these options for the schema, how it may change over time, and whether you just need to sample the data, especially for large data sources. In order for you to test it and get it rolling, you may not need to wait on 3 million rows to be read every time. Just sample the data to get started, and then you can go through several different other options. But we'll come back to that in just a moment. But once we've got the source defined, then notice I can click this plus sign, and it brings up my transformations. What can I do with this data? Well, I can create a new column based on some value, and then after that, I might want to stringify something, some type of object. And let's see, then I might want to sort it, and then finally sync it. Syncing it or is the destination. So notice the tiny little icons that are easy. You see here's an arrow pointing into a database, so that's what we're reading. We're creating new rows or combining, new columns or combining columns. We're converting column data into JSON. We're sorting it, and we're writing it somewhere. Now, whether that's logical or not, I don't have any data to show you, but at the same time, I could have created yet another source. And then I could have brought in a join. And then I could join these two together if I created another intermediate set and pull these two together, or I could split the first one off into two different paths. So it all depends on how complex your data flow is, how many sources, how many destinations you need, as to how complex this one data flow could get. All right, so let me call this one demo data flow, even though it's not complete. And then we'll, whoops, I have to publish it. I bet I can't publish it because I need to follow. Yeah, I can't publish it. So I can't really reuse it yet until I fix all those problems. But if this were complete, then I could go back to my pipeline and go to my data flow and choose that data flow, whatever I published it at. Well, there it is right there. It's not published yet, but that would become my data flow that would be called after I copied data and be another step in the pipeline. So a data flow is not the pipeline. It is an activity in the pipeline to transform data. Now, if it simply read and wrote the data, why not just use the copy data? Copy data does not involve any transformation. It's just copying from one place to another. But if there's any other work that needs to be done on it, then you use a data flow. All right. Let's go back through some of this. So when you create the data flow and you choose the source, because that's the first thing you would normally choose, the integration data sets are the reusable entities that can be used in this and other data flows. And they're basically defining a schema. These are not Spark based. The inline data sets, the second one, are. And then the Workspace DB is so that you can choose a database that's already part of Synapse Workspace. The same functionality exists in Data Factory, except Workspace DB does not apply. It's not even available within the Data Factory. It's either integration data set or inline. And then after that, here are the different types of transformations, as I demonstrated a couple of them. Multiple inputs and outputs, that's for join and split, conditional split. Schema modifiers, new columns, changing the structure of the data set itself. Formatting, row modifiers for usually sorting and filtering, flowlets that are not available yet, and then finally a sync. So pretty simple, straightforward concepts here of how you want to transform the data. Here's some examples of some of them and how they're set up. And I did all these examples earlier, so I'll need to get through some of these due to time. And row modifiers. And finally, the sync. So once you've got your data flow complete, you can integrate it with a pipeline. As I said earlier, it can be added to the pipeline, or when you're in the pipeline, just drag over a data flow activity, as you see right here, and enter the name of the data flow that was created earlier. All right. That's it. Please post some of your questions here. Hopefully you enjoyed it. I am very sorry about the first half. I'm very embarrassed that it wasn't checking with the right screen that was being shown to you. But please go to the WebAge website if there's any particular part of this that you're interested in. There can be some custom classes created for you, or simply use the Microsoft DP203 course for most of the topics that we cover here. I actually introduced concepts from 3 or 4 different courses, but most of it would be the DP203. Can you share your PPT with us? Please contact someone at WebAge. They have the slides and they can give you those to you. So the slides would be available to you, but just ask WebAge for that. So last 2 questions, yes. Well, I hope you enjoyed it, and I want to make sure I leave at least 10 minutes here at the end for questions. So please, if you have any questions on the topics, the technology, the services, what is the best practice to set up dev, testing, and production environments? Well, it depends on how clearly you want to isolate development from production. And in most companies, you want a very clear distinction. I would actually start with separate subscriptions. You have a subscription for your dev environment. They would set up their own workspace. They would set up, all the components that they're building within their own pipelines. And then your production environment would depend on DevOps procedures to port that code over and deploy it to a production environment. Version control, like was asked earlier, would need to be supported with let me see if they've moved that. See if I go back up here to develop. Where'd it go? It was kind of a hidden location. Let me go back up to, no, it should be under develop. Let's see if it's under manage. There it is, right there. So under manage git configuration is where you would define where is your repository for all of these components. Even though much of it is graphical, behind the scenes it is all code-based, usually JSON declarative form more than anything else. Now your notebooks are also text-based, so those would contain the different languages that you use within your notebooks. So my recommendation, best practice, is to have totally separate subscriptions so that you're also managing the cost separately. Testing and production might be in the same subscription, but remember too, you've got to manage security. So security could be done with different resource groups in the same subscription, but usually production is going to cost much more than development as far as the actual processing of the data. Can I use the Azure free account to set up Microsoft Azure Synapse Analytics? Yes, you can. It's for a limited time, and you also get a certain credit. So be very careful about leaving your pools running. A SQL pool that is dedicated would not necessarily stop. So in fact, I didn't create one here. Let me go ahead and create one for you. So a dedicated, I'm going to call this one a SQL dedicated. And notice this is $15 per hour. Not so bad in a production environment, but that's quite a bit of throughput. DW1000 is a reasonable production level, but make sure this is not too high. $1.51 is more tolerable when you're just trying to play with it. But if you forget to turn this off, that's $24 per day. That adds up, $100 within 4 days on your own account. And sometimes these free accounts will kick in because you had to enter a credit card, and they'll start charging your credit card after a certain amount. So definitely look at the state of your SQL pools, particularly your dedicated SQL pools, because they're gonna cost the most because they include a cluster of machines for storage. The others can be told to be turned off after a period of time. But notice here I'm deploying SQL dedicated pool. The built-in is serverless, and it will automatically stop if it's not being used, and you won't be charged for it. Monitor everything carefully. Very good question. So yeah, you can use the free account, but it's very limited. You're not going to be able to use it full time because it does have a limit on the capabilities. Any other questions? Was there anything this morning that you wish you could have seen? I've got 5 minutes I may be able to go back to, but hopefully the description of it made it a little bit clearer. All right, I hope you enjoyed it. That's a fun topic. I love teaching the class, so if you ever get a chance to take the DP203, please ask for me. Oh, artificial intelligence, machine learning integration, yes, that can be included as well as within Synapse Analytics, because we have a separate service called Azure Machine Learning that could be introduced within your pools as part of your pipeline. Once your data gets to a certain state, like gold standard in the data lake, you could use a pipeline to activate machine learning, maybe for training your model, maybe adding more data to your data set within the pipeline based on the response coming back from machine learning, such as trying to track fraud. Is there anything unusual about this data? Is there something wrong about this data? You could rely on machine learning models to give you that information back. Very good question. That's another activity. Now there is a, before you leave, oh, I've already lost 40 people, yikes. There is a link that I want to post in the chat. This is a evaluation. Again, I hope you enjoyed it. A lot of fun, and